So yeah, so I'll give you a little bit about my background. I mean, I started here back when we were still called the Pro Metal Division of Extruded Hone in 2001.
Yeah.
I'm a physicist by training. I came here, I was working as a project manager doing, like one-off machines, assembly lines, old-fashioned like old-fashioned heavy manufacturing.
Yeah.
I started off in like PLC controls, grew into mechanical design mechanisms, instrumentation, and doing all that kind of stuff. And then in 2001, I was getting a little bit restless. Building one-off machines kind of sucks.
Yeah.
And so I came here to ExOne, to ExOne, and it was 2001. And yeah, in my interview, I saw it was the RTS 300. It was one of our first models of binder jet printer, and was using an ancient frickin' printing technology, and place that barely ran. I mean, it ran, but it wasn't all that great. And boy, I tell you what, boy, did I fall in love with it the minute I saw it. I mean, I think it was, for me personally, as a designer, as I say, I'm a physicist by training, not a mechanical engineer. So I never learned certain skills. I can model really well in CAD, but I can't make a drawing to save my life.
Sure, yeah.
So actually getting parts made was always kind of like my biggest complaint in manufacturing. Yeah. And then all of a sudden, oh wow, this is like, I just have to design it and then I can hit the print button and this is going to change my life forever. Had a little bit further to go.
Yeah, it's a little more than that, but yeah, everybody felt the same way. Yeah. That's cool,
so
man.
It's been a long, not a long 20 years. It's been a fast 20 years actually.
Yeah.
But, it's still, I was watching one of your other podcasts. I'm also a believer that this is actually still the beginning. Like this has been 20 years of commercialization to industrialization. And, the basic commercialization was done a long time ago. Making it truly industrial, that's the challenge now.
Yeah, no, it's an interesting time. I was just talking about that a little bit with Filipos about, how it is just beginning, and it's kind of, there's so many interesting things happening, but it's been evolving to the point, especially for production, and trying to get as much parts made as possible. That's always been a barrier and continues to be, but, you see companies kind of stepping up and opening up what can be done. And I know, obviously, ExOne has had some news on doing that with larger build platforms and coming at things a lot differently, even on the metal side right now, and with binder jets. So that's exciting. I've worked in laser powder bed fusion for the last 5 years, but been around it for a while now, a couple decades, and as well as the other technologies. And I love them all. They all have their place. They all have different things that are really pushing forward what can be done. But I think that's also the challenge for these companies. Is adopting, which technology is it, that I should be investing in, it's an interesting time. And what I saw recently too was, with binder jet, it's been very interesting to me because I have a lot of conversations about things that are happening, talking about what's happening with HP and also what's happening with desktop metal. Obviously, huge investments happening there. But I've always known ExOne was pushing binder jet and developing it. Am I wrong about this? Before all that, yeah.
Well, we've been doing binder jet metal since 1997.
Right.
Like I say, my first binder. So my claim to fame here, how I became printhead guy, technical fellow, is literally it started for me anyway. It started because the company was basically 6 people, and we had this new platform we wanted to create called the R2. And literally I was at a meeting, it was like our weekly whatever meeting. And the boss is like, well, Larry, you're doing that. Mike, you're doing that. David, you're doing that. So Dan, that leaves you. You're the R2 product champion. So you got to go figure out what the R2 product is. And, that just kind of started a multi-year development of a platform that kind of, like every platform and additive, it was shipped way before its time. It wasn't at all ready to go. I spent 9 months at my first customer installation site installing a machine that didn't even have a printhead on it yet. So,
oh boy, typical stories though, man. I mean, you gotta get it out there and have people tell you this isn't working. This is not what we expect. But that's how you tweak it and have it become better and better. You know, that's part of the evolution, is having the feedback from other people that are not on top of it every day, but you know, the customer. What are they thinking about what we're doing?
That's right.
That's interesting.
Right. And your window for opportunity is small and always closing. So yeah, I mean, you know, you march out there when you have to, and yeah, so whatever. I mean, it had a happy ending. I can say the R2 machine is still used in our job shop. I still have an R2. I have a couple out in the field still. They're like circa 2005 machines, still running every day. So, you know, the machine worked out eventually. Just a bit of a rocky start.
If it's still working, it worked out. Yeah, that's awesome. Well, cool, man. I mean, you know, a little side topic on that. Just what's been going on. You know, ExOne has been really famous for what they're doing. You know, with the sand side of it, the sand casting side of it, and stuff. I mean, that's a big strength, obviously, and that's really awesome to see that develop and what it can do. So, you know, developing everything for the metal side of things. You know, what is it? 3 machines that you have out on metals? How many machines are actually?
So right now, right now we have 3 machines that we are actively selling. So we have, of course, our Event Plus with ACT. It's basically an R&D kind of machine, like 0.67 liters, 160 by 65 by 65.
Okay.
But it's really great for doing tensile testing, you know, like material development. It's very popular in like expensive materials because, you know, you don't want to invest in some kind of full production line until you've, you know, demonstrated something at the small scale. So we have the Event as a great little intro machine. And frankly, if you're making the transition from dealing with billet to powder, I mean, you want to learn powder on a smaller scale. But then, of course, we also have our 2 full-on production machines, the 25 Pro, 25 liters, 400 by 250 by 250 built.
Nice.
It's like, you know, 6,000 cc's per hour kind of machine.
And that's a huge jump, right? That speed is cc's per hour. Yeah.
I mean, listen, there's a difference between production and toys. I mean, you know, you can't. I was looking through some old documentation on some other machines related to a different project I'm working on, and I was looking at how, you know, all of the major OEMs used to rate their machines in millimeters per hour.
Mm-hmm.
And, you know, when you convert those old millimeters per hour on some of the high production machines, they're running less than a 1,000 cc's an hour, you know, and we're running on our 160 Pros, we run at 12,000 cc's an hour, right? I mean, you're turning, you know, 1,200 pounds of powder per day. So it's a little bit different scale. It's a little bit different problem to solve. But, you know, what's really strange, what's always, you know, again, I'm not a business guy, I'm not an economics guy, but what's always fascinated me about this industry is how it's so totally driven by build rate and build volume.
Sure.
It's really a question of dollars per rate times volume. And it's really how do you manipulate those 3 numbers to get that as small as possible. And we all historically have tried to get there the same way. Faster machines with bigger boxes, you know, like that's how you get the amortization table right, the end.
Yeah, no, I mean, it's exciting to see what's going on. You had a lot of things happen with you said the larger machine is the X1D1, is that correct?
No, so the X1D1 is actually a automatic guided vehicle for our larger platforms.
Okay.
We've had several requests. There's a lot of large OEMs right now that are totally rethinking how they want to do planning. I mean, so as I say, I used to do one-off machines. And so I did some machines for the former GE Transport. And when I say literally you design one machine, it's here's the square footage. We need to move the product this far to this far. This, you know, like it's very, you know, you put in a conveyor and you put in a gate and it's very straightforward kind of stuff, right?
Yeah.
A lot of manufacturers are wanting to move away from that. They don't want to have to dedicate floor space to conveyors. They don't want to have to dedicate floor space to control pulpits. They want to keep the floor space as open as possible, as reconfigurable as possible. And so what they're asking us to do, and not just us, I mean every OEM,
sure.
they're asking us to get rid of conveyors, get rid of hand carts, get rid of our old boss, Larry Rhodes, who founded Extrude Hub, used to say that what we're doing is we're trying to turn manufacturing into compufacturing. You know, we're trying to take the man out of it more or less at various stages of the game. And
the automation side of it,
the automation side of it. And so the X1D1 is a big piece of just, frankly, build box coordination, right? I mean, like I say, on a 160 Pro, you're dealing with a box that might have 1,200 pounds of powder in it. And, you know, you want to move that around from one station to another station, curing, depowdering, your sintering area, all that kind of stuff. I mean, you don't want that to be done by people driving carts.
Yeah, no, take out the human error factor there as much as you can, and it's a lot to do. I know that there's a lot of even temperature control issues.
Temperature control. Hey, batch traceability is a huge thing for our customers.
Materials,
they want to know. They want to know that this job that came out of printer A just went into oven C and it's going to go to depowdering station F 10 hours from now or whatever. I mean.
Right, it's got to be on that schedule to be the part that it needs to be. That's awesome.
And they want as few touches as possible. They just want that back end to flow, just like it does in a regular assembly line. That's really what they want from us, and that's what we're trying to give them.
Yeah, that's awesome. So to back it up a little bit too,
Sure.
This whole technology is binder jet technology. Can you explain what binder jet is?
Oh, of course I can.
Yeah.
That's one of my favorite things to do.
I knew it would be. Yeah. I'll let you go for it, buddy.
Yeah, so when we talk about binder jetting here at ExOne, we talk about the core of binder jet, and the core of binder jet basically revolves around 6 things all operating in perfect concert. So if you take the first 3, you've got essentially, I call it the jetting tool, your printhead, whatever. You've got your jetting tool, your binder, and your powder, and you've got to have those things working, in perfect harmony, meaning that you can't just look at, what kind of printhead am I going to get? It's got to be, okay, what kind of printhead am I going to get for what kind of life, for what kind of binder formula, because I'm jetting on what kind of powder. And so you get those first 3 things working really well together first, your jetting tool, your binder, and your powder. But unfortunately, of course, as you can imagine, that only gives you 1 droplet. So, it's essentially a gluing process. You jet this little droplet of glue into the powder that binds a single voxel together. To turn that into a 3-dimensional part, now you have to take these 3 core elements and build 3 more core elements around them, meaning the actual platform itself and all of the tending and material handling functions that go into that, your control system components like your pumps, your valves, PLCs, all those kinds of things. And then of course your recipe execution engine, like how am I going to slice my files, my layers, how do I lay out the bitmap, what's my laydown strategy, all of those kinds of things. So those 6 pieces working together, the jetting tool, the binder, and the powder substrate and powder substrate preparation, the platform, the control system, and the recipe execution engine, those 6 together, that makes up what we call the core of binder jetting. And so you just do that layer over layer over layer, wash, rinse, repeat, spread a layer of powder, print an image of glue, get ready for the next layer, and over and over and over. And that's the basics of binder jetting.
What is does the binder change for the material? How does that work?
Yeah, sure. I mean, so if you think about, okay, so let's talk about what you already mentioned, our sandcasting business versus our metals business.
Sure.
In our sandcasting business, that I tell you why the foundries and the customers and the pattern shops love our stuff is because it's straight up material. We're not asking them to do anything funny. It's foundry sand. It's foundry binders, like for fuel alcohol and phenolic, and it's like what they use every day. There's no special training other than they have the machine and it's a new technology, but the materials are something they're intimately familiar with. And so those binders are their own class, and they're really just sand binders. But then in metal binders, we kind of have a completely different, the binders in that industry are driven by the need to, not only hold the casting shape during the casting process, but those binders have to successfully burn out and decompose before, like the casting operation's over, right? Because you got to break that sand back up, wash it out, So those binders are all tuned for that kind of an atmosphere, or for that kind of environment and production. Metal binders, on the other hand, are a little bit different because one of the things that we have to do in metal binding is make sure that the binder itself throughout the rest of the process. So I didn't really talk about the curing and sintering steps. I can do that. But
Sure.
during sintering now, you have this powder. We don't have all of the waxes and whatnot that you get from the MIM industry, but it is ultimately bound together with polymer when it goes into the furnace. And so you need those polymers that you use in your metal binders to burn out cleanly. You can't, if you're trying to make Inconel 625 or Inconel 718, there are very tight oxygen and carbon specs on those kinds of materials. And so whatever is in your binder, that has to burn out cleanly or you start affecting material chemistry and now you don't have a process that's worth anything.
Right, right. And at the same time, a lot of things I heard like as feedback on the process, I'm just wondering about what's improved. I know surface quality was kind of like a knock compared to maybe laser process. So I know that's been improved. What happened there? Like, I mean,
It's simple. It's simple. We conquered powder. When you look at it, really, they specialize in free flowing powder, like, because of either the way they've chosen to spread their powder, compact their powder, whatever, they choose free-flowing powders. Well, free-flowing powders largely are going to be larger diameter, right? So a typical cut in a laser machine might be 10 to 40, it might be 20 to 50. And so there's kind of going to be that inherent bottom end of theoretical accuracy, right?
Yeah.
But now that we're using powders with a D50 and 9 microns, and we can go in layers as thin as, I mean, if you really want to do super high precision printing on binder jet, you really can. I mean, we have a process that's like 20 micron layers at 800 DPI. And,
nice.
The parts are
beautiful. Yeah.
Yeah. I mean, so what's really happened is that, we were stuck in the same rut of having to use free flowing powders, like we just were having issues. We knew that we had to get to fine powders, but getting those things to flow and spread evenly and make, a 30 micron thick layer and the layer underneath that's wet and evaporating. And, there's just a whole lot of stuff going on.
Yeah.
And you're trying to do something really precise and really exacting. We finally figured that out. And, like we put together like a program over the course of, I had my phone on mute, but it was still vibrating on the table. So.
Yeah, all good. So, but you were saying that's how the surface quality improves so much is because of those advances.
Hey, listen, it's true that things matter as long as you make everything matter at once, right? Like there's no point in going to a 9 micron powder if you're going to use a 100 micron thick layer.
Yep.
Like there's certain, if you're not taking advantage of it all, there's no point in taking advantage of any of it. So like in our super high definition processes, like any printer, I mean, at the end of the day, we are all printers in binder jetting, right? And so we all kind of have to recognize that printing plain black text and printing full color photographs are two different settings on your printer.
For sure, yeah.
And the same thing is true in 3D. So if you want those super fine features, super thin layers, that does cost you time. But it's kind of cool, right? Because it means that you can play around a lot with those variables of time, surface finish, layer thickness, DPIs, and you can really say, okay, what does this application really require? And that's one of the nice things about binder jetting too, is that, if you have we have settings on our machines that, just like on a typical machining center, we call it hogging it out, where you're doing 200 micron layers, you're at 400 DPIs, 150 picoliter drops, you're just hogging out material because the shapes you're making,
they don't need the high accuracy.
Right, that's all the more critical they are. It's understood that it's a near net process. They're going to be doing some post-process machining anyway. So you hog it out. And so you can configure your machine for that, but you can configure your machine for making we make just to show off.
Sure, no, I love it, man.
I don't have any with me. I unfortunately give them away, but we make these little tiny fleas. And I mean, the legs on the fleas are less than a 0.5 millimeter thick. The wings on the fleas are
now I gotta get one of these fleas. I never thought I'd say that. I want to get some fleas.
I mean, these things are just amazing to behold, and could not ever make them in a MIM process or any other process. I mean, it's just,
that's cool.
It's amazing how
it
this
shows
can be
precision.
pivoted.
Yeah.
Yeah.
Shows precision, and like you're saying, yeah, fine-tuned instrument and what you can do with it. I got to see that flea, man.
Yeah, no, I'll get some.
Yeah, that's way
Well,
cool. Yeah, so I know that you know, like you were saying, I saw some of the headlines being it was a larger build area with 3 times print speeds.
yeah,
Now,
so
is that for X1 or is that across the board in binder jetting? Like what exactly is it doing in the industry?
let me talk about that exact press release. So that's the press release of our Newman Event Pro that we're doing with Siemens. So basically what that is, you know, the Event Pro is a great machine, it's a great platform and our customers love it. But, you know, pretty much our number 1 and number 2 complaints are that it's just a little bit too small and it's a little bit too slow. And so what we decided, we broke down through a whole bunch of different, again, looking at the dollar signs per build rate volumes and trying to figure out, okay, where are our customers? Where can we take our customers? It's going to make them, you know, happier. Did a lot of research, interviewed a bunch of people, and basically, you know, there are some formulas that we use internally. I'm sure every company that designs their machines has, you know, standard, this is the estimate of how to get there kind of stuff.
Yeah.
So we struck on this 275, 2.75 liters. It's like 220 by 160 by 100 deep, I think.
Nice.
And, you know, it's going to be like a nice, it's like a little bit bigger than like a tissue box, let's say. It's going to build at 500 cc's per hour. So you're going to do that like in about a 4 or 5 hour run, something like that. You'll get a couple of boxes out of an 8-hour shift. We think that for somebody just like kind of moving from proof of concept in event type space to just below the point where you're ready to really go after a 25 Pro or a 160 Pro and really get maximum productivity. We wanted to have some kind of stepping stone there. Again, you know, when you first, especially for our customers first getting into powders, it can really be a leap, you know. I mean, it can be you try to prepare them as much as you can, right? Of course. I mean, we have hundreds, thousands of pages of documentation about safety and movement protocols and storage protocols. But, you know, when you actually get into the work of implementing a powder-based manufacturing system, there are lessons to learn.
Yep. And
the easier you can make those lessons, I think, you know, ultimately customers are going to appreciate it, especially if you can really hit that price point that makes it easy for them to say yes and really get started. Because I tell you, so many people, Adam, are so excited about binder jetting. I mean, the competition that's entered the marketplace has been quite possibly the most important part of the X1 company's development ever, is having competition, you know, having validation, having other people saying, yeah, you know what, we think your customers are so cool, we're going to go after them too. That's been great for us.
That's a huge validation. Yeah. It's saying that this is a viable technology if everyone's wanting to jump on the bandwagon. So that's awesome. Yeah, really cool. And so now with that new machine and that partnership with Siemens, is there an evolution there of size and speed?
Yeah, you know,
it's
an evolution. I mean, the thing of it is we're kind of funny. So over the last 20 years, like literally what I've seen us do, and this is actually not a criticism of X1, it's like just kind of how we've gone.
Sure.
So we went from the R2 that I made, that was 8 inches by 8 inches by 6 inches deep. And then we decided we wanted to try going really small scale and doing the dental market. And so we made a machine that was like 60 by 40 by 25.
Oh, wow. Okay.
But at that scale, we figured out a whole lot of things that, frankly, we weren't figuring out at the R2 scale. You know, like you're able to study a lot more interactions in a lot more smaller space. And so you can map certain fundamentals a little bit better. And so we would take the learning from the R2, scale it down, and make an R1. But then we scaled that back up to make a machine that actually we never released. It was just an internal production model. And then we went to the M-Flex, really big. And then we went back down to the N-Event to say, hey, you know what, there's a lot of new technology here on the M-Flex. Let's scale it back down and again, really make it studyable. That gave us the N-Event Plus with ACT and our our advanced compaction technology, unlocking all these superfine powders I'm talking about. And then we scale that back up to the 25 Pro and now up to the 160 Pro. So I'm predicting our next machine is going to be about the size of a matchbox.
Sure, go back down, raise back up.
Right,
hey, but that's where also the precision is made, right? Because I know when you're looking at, like you're saying, you don't have to turn over as much powder. You're looking at one area of building things, and you're doing things you could fine tune inside that area. So then you look at how you could scale that up, right? I mean, that's just logical, I guess, for the process. But that's way cool. I mean, it's been a wild ride. So what's been going on? I guess that's all been part of what's been happening with ExOne during this year, 2020, because the pandemic has slowed a lot of progress down, but you guys have been developing this for a while. So I'm really happy to see the technology pushing forward at this time. That's awesome.
Yeah, well, I mean, we communicated this to the market. I mean, one of the things that, it did help us, frankly, is we had a very strong backlog heading into COVID. And we've actually have continued to build our backlog in COVID. I mean, and I'm sure this isn't just ExOne, I'm sure it's almost everybody. When you're talking about really expensive production platforms, that's a sales process that can last 9 months, a year, 15 months. So, to have like a 3 or 4 month blip might be a really big deal, but since you're on such a long time scale anyway, it's not quite as big of a deal.
Sure.
So, that certainly helped. What else can you do but keep moving forward? I mean, like all companies, we had a couple of layoffs, not very many.
Sure.
We were very fortunate in how few people we wound up letting go. So, that had a little bit of an impact. But, frankly, the ExOne business is strong. I mean, I talk to new customers every day, excited to get into a statement of work or get into a machine or just buy parts. It's, this is a great time to be in binder jetting is all I can say.
Yeah, no, it is. That's really cool that's what's happening now. Like we were saying, 3D printing, manufacturing in general is doing a lot of interesting things at this time. And to see the technology push forward in binder jet right now is super exciting. So I'm looking forward to much more from ExOne. I know that we have some things in common too. I mean, this has been a stressful time. Talk about some of your hobbies. I know it sounds like we're both musicians here a little bit. Have you been getting to do any of that? What have you been doing with your spare time there, bud?
I tell you the truth, I haven't been able to do much music in a few years. So, I mean, I used to play I was lead singer, bass player, songwriter.
Nice.
I was in a band from, 96 to 2013.
Wow.
In the area.
Sweet.
Hey, listen, we were never famous. It was just fun, right? It was me and a bunch of the boys, and we got together once a week to practice and once a week to play out, it was great. Yeah. And, but I tell you what happened is, frankly, my kids were getting older, around 2011 or so. I was looking for something to do with the kids, and my son and daughter and wife and I all got into Taekwondo.
Nice, and, cool.
So we all went through like Taekwondo black belt training together. My son and I are 3rd degrees. My daughter's a 2nd degree.
Way cool.
My wife's a 1st degree. So, that like kind of got distracting for a while. My son and I would travel around a lot, compete. And,
that's a great distraction.
So, I
had my daughter in there in kindergarten, 1st grade, but she wanted to move on to something else, but the first couple of years, I got her into the discipline of doing stuff like that. That's great.
That's cool. That's cool. Yeah. But so now, my son's 18. He'll be 19 next May. My daughter's going to turn 22. So I still have the bass. I still have the bass down in the basement. I still have my keys up in the attic. I've got an old Akai 1212 recorder mixer down in the basement. So
cool, man. Yeah. That's awesome. Yeah, I have a few of those laying around here. I had more stuff that I had to put from my man cave away a while back. But, the 90s played a lot of music and stuff like that. And
dude, the 90s was the best.
Yeah. That's when I was playing a lot. Now it's just I'm a dad. I play when I can to have fun myself. I usually end up playing acoustic guitar and singing, just ruining cover songs, basically. but I love all of it. It's a good thing. And also my daughter's been getting into piano during, before the pandemic, but now she's more into, the virtual classes and stuff like that. So just having that as a hobby is a blessing right now. It's something to do together and have fun with. So we have a good time.
Well, it's weird. My new hobby, to tell you the truth, that like kind of came up. And so this is, I'll go ahead and be a little open reveal, a terrible secret about myself.
Awesome, man. That's an exclusive. Yeah.
Oh yeah. So my wife has turned me into like a closet fan of the show Project Runway.
Okay. Yeah.
Show about clothing designers.
Yeah. Yeah.
Well, so I'll tell you how the pandemic first hit for me, right? We were just wrapping up TRX in College Station, Texas in March.
Okay.
I flew out to, that was like March 1st or 2nd through 4th or something. I flew out to California for an overnight trip. One of the salesmen asked me to come out and help him with an introduction to a new potential client. And so I flew out there. We were going to fly up to Seattle the next day to meet somebody else. And like that Thursday, it was the 5th, that Thursday the 5th, I was in California for 24 hours before basically our second customer we were going to go see canceled, said, we're not taking any visitors. I was lucky enough to be able to catch a red eye home, and I made it home Friday. And why it's so clear for me is because that happened to be my birthday.
Oh, okay. Well, happy belated, but what a time.
Thanks.
What a time. Yeah, right?
Yeah. So the very first phone call I get practically from the time I hit the tarmac in Pittsburgh is my boss at the time, Rick Lucas, calling me saying, hey, Dan, is it true that you were just traveling in California? And I'm like, yeah, Rick, dude, I was there for like 24 hours. I mean, I was barely there overnight. And he says, yeah, well, you're going to have to go on quarantine for 10 days. Because, California was a hot spot and everything changed. Like, it was overnight, man.
It was, yeah.
And it was so crazy because at that conference, like, COVID wasn't really even on the schedule. And 2 weeks later, it dominated the conversation. So,
yeah.
I mean, it was like that.
Yeah, that was for everybody at the time. It's funny you're bringing up the clothes and different things that were going on, right? Where you start to talk about.
Oh, I'm sorry.
Yeah.
So my new hobby.
Yeah.
So okay, I get this quarantine, and I'm like, oh man, okay, this must be serious. We better do something about these masks. So, and I don't know. I don't know. I guess I was too lazy to go buy one. So I happened to like see this tutorial online about how to sew your own cloth masks. And I watched it and I'm like, oh, I can figure that out. And so I like dug up my wife's 20-year-old sewing machine, cleaned it and oiled it, and taught myself how to make masks. Taught myself how to sew and taught myself how to sew cloth masks.
Cool, man. Yeah.
And so now I've like started making some clothes for her, and I'm putting together a 120-week work plan where I'm going to go win Project Runway.
Dude. That's awesome. You might want to take my daughter with you. She is an amazing, she's 11 going on 12, but she's been in sewing classes for the last 4 years. And it blows me away because right before the pandemic, I went into her classroom and she's like, oh, I want to show you this new purse I made. And I was like, okay. And I was looking everywhere else, but right on the table in front of me, because there was this gorgeous high style purse that I thought was the teacher's bought purse because unbelievably sewn in detail everywhere. And it was her, that was the purse. And I was like, you made this? So I'm keeping it down because she's in virtual school right here.
Right.
Let me take this off just so I could hear myself. I bought her a sewing machine. I haven't given it to her yet, so she's going to get her own sewing machine soon. So that's a little exclusive
that's so
here too.
Cool.
Yeah,
awesome, man.
Yeah.
Awesome.
So because I definitely want to bolster up what she's doing there, and she's so amazing. And she still takes the class as a small four people only. So she still does that, but at the same time.
Awesome.
That's kind of been sitting in the closet here for a little while, waiting for the right moment. But now that you're talking about
that's so spectacular.
I'm going to have to take it up too because I have the awesome machine at home to do that. I'm just trying to keep a little secret there. But yeah, that's real cool. That's an amazing parallel there, man.
I have to tell you, as an engineer, as a scientist, whatever, I have found that fabrics are amazing. Like, I mean, so like I say, I made my wife this one thing, and like. One of the weird things about clothes is you make the pockets first.
Yeah.
Don't know why, but whatever. And like the instructions are really like oddly written if you're not used to them, let's say.
Yeah.
And so like it's telling me things like, okay, flip this, sew a seam here, turn it over, do this, do that. Okay, now flip the whole thing inside out and do this. And it's like, you flip the whole thing inside out and you're like, that's what I was doing? I mean,
yeah, that side looks horrible.
Yeah, and like just the way you can like work with fabrics and build in structures and like support, you know, like if you put the right kind of tension here and the right, I mean, fabrics are just like becoming a fascination for me of just like
that's awesome.
Piecing fabric work together and seeing what kind of shapes you make based on hidden seam work. And it's actually turned into kind of just a weird thing for me that I find just really interesting. I've never worked with fabrics before, right? Like I've always worked with solid objects or maybe sheet metal, but you know, this was really kind of new, very cool for me.
That is. So the next project Runway winner right here.
Well, it's 2.5 years. It's a 2.5 year plan. Like I know. It's a 120-week plan. So
yeah, that's awesome, man. What a
stage gates built in there and everything.
Yeah, well, yeah. What a cool hobby to pick up. I mean, it's I could see myself getting into it now when I release that new system. I'm gonna pull out. It's the same one she has in class, so it's a really nice setup.
Awesome.
Tried to be silent there. I know I'm loud over here. But anyhow, yeah, man. So, hey, wonderful to have you here, Dan. Is there anything else
thanks, Sam.
Talk about while we have you here?
Oh, geez. I guess I'll just say I'll make a quick plug for ExOne. I mean, as you know, we've been in binder jetting the longest time. Experience counts. Over 20 plus materials that we've been able to demonstrate running through our machines. We always say it. We can do sands. We can do metals. We can do ceramics.
Yeah.
And we've been doing it longer than anybody else. And you know, when you look at the economics of our truly production machines, I mean, not only are our prices competitive, they're frankly the best out there. And you're going to find the most complete solutions from us. And yeah, I mean, hey, and ExOne is hiring. We are hiring a ton of people in every asset of the business, whether you're technical, whether you're marketing, whether you're sales, whether you're service, whether you're whatever. We need scientists, we need machine builders, we need accountants, we need everybody. We've got so many jobs posted on the ExOne hiring page. It is a great time to be in binder jetting. Please apply. Hit me up on DM on LinkedIn. Look me up on LinkedIn. My handle there is Jethead. So if you do n.link.com/Jethead, you'll come right to me.
Perfect.
Find me on Twitter at Dan Techno Guru and follow us at ExOne.
Yeah, and all those careers and jobs, it's ExOne.com, right? ExOne.com, and I'll put a link to that. A description of that with the link. And
you know what? We wanted to talk about women in 3D printing.
Sure, let's go on it, man. That's awesome. So
how did you?
Yeah, go ahead.
Yeah, I mean, so I'll tell you my start with it. To be honest, I was really kind of, I mean, like I didn't know anything about it. I kind of thought it was for women, right? It's called Women in 3D Printing. And then how I actually got introduced to it, like formally, was I met Janet Carr from Link 3D.
Awesome. Janet's great.
Janet's amazing. She's amazing. I should plug our podcast while I'm here because we're working on a podcast together called Beyond Industry 4.0.
Awesome. Well, check that one out. Yeah.
Yeah. She just asked, hey, are you going to the Women in 3D Printing, mixer tonight, social hour and happy hour? And I was like, oh, well, are men allowed to go to that? She says, of course. And so I went, and wow, what an amazing group of women. And then I went to my first like actual Women in 3D Printing
happy hour.
Well, but one that was not just a happy hour, like where they actually had a presentation, a panel discussion, like a whole thing. And I was like, wow, that was really like one of the highest quality presentations I've ever been to. And then they asked me, like I came and spoke at one once. They asked me if I'd just come and tell my story at one of the gatherings. And that was really great. And I had an opportunity to meet Nora Torre once, and not too long ago, actually, again, through Janet Carr. Yeah. And wow, what an amazing woman she is. And just the people that I've met there, the things I've gone to, Women in 3D Printing, I'm just a huge fan of. Our lead counsel, Loretta Bennick, is a co-founder of the Pittsburgh chapter. That's, the ExOne company has actually a very long history of putting women in powerful positions. I mean, we have our global marketing director, Sarah Webster, was recently promoted to chief marketing officer. You know, like I say, Loretta Bennick is our head counsel, secretary of the board of directors. So, you know, I've been so impressed by the women I've met in additive, actually the women I've met in manufacturing in general. Boy, I tell you, what a great organization.
Yeah, it is. It is. That's really cool that's how you got involved. I've been on and off talking with Nora and everyone else over the years, and working with Janet too. But yeah, that big event they have coming up in January, the Type Conference in January. Conference. Yeah. Also, thank you very much for joining me on this. Oh, look, hey, he's back. He's back to close it out. No. All good, man. Yeah, like I was saying, no, it's been great chatting with you, Dan. And
thanks for having me on.
Yeah, looking forward to keeping in touch, and I know I'll see you around. So let's definitely keep chatting, and we'll see you soon, buddy. Thank you so much.
Okay, take care.